In my first video in this series of Unreal Engine for C++ programmers, I used the blank project without starter content. In this second video, I remake the Bananas 5 project with starter content, and from the very first steps I show how to use GitHub with the project. I highly recommend to watch the first video, since in this episode I will not explain the details that I had explained in that first video. In the second video we are going to make a C++ actor class, and I'll explain the C++ intricacies. Create then a project Bananas 5 and select blank C++ and starter content. Always select C++ since Blueprint classes are available ubiquitously in C++ projects too. When I publish this project on GitHub, I will exclude the starter content from the project to make the project upload size as small as possible. In this blank with starter content template, the game editor opens the minimal default map in the viewport. Don't touch anything on this map. Let's create a copy of it in our game content folder. In the content browser, create a game content folder. Locate the minimal default map in the starter content folder and drag it over to the game content folder, and after dropping, select the copy command and rename it to Bananas map. Open this new map with double-clicking and delete the chairs, table and sculpture, then save the map. Now, open Edit Project Settings and in the Maps and Modes panel, set Bananas map for both Editor default map and Game default map. Now save all, and we are going to prepare a GitHub repo for the project. Create a public or private repo with exactly the same name as our project name, Bananas 5. The name could be different. However, when you clone your project on another computer, it will create a local folder with the same name as the repo. For description, enter an Unreal Engine 5 experimental C++ application. Don't add readme or gitignore. All these will be added automatically when we are initializing source control in our project in Unreal Engine. Copy the repo link created on GitHub, since we need this link to connect our local repo to this remote repo. Before initializing source control in our project, for GitHub support you have to install Git from gitscm.com and Git Large File Storage LFS support from Git Large File Storage website. Visual Studio has excellent GitHub support. Still, I recommend installing GitHub Desktop since it has some easy-to-use features and it is more lightweight than Visual Studio when you only want to do some GitHub tasks. You should be aware right away that apart from the custom C++ classes, Unreal Engine works only with binary files. Even blueprints are saved as binary files. So, when a new version is committed in the repo, a new copy is uploaded. This storage constraint is not optimal, but this is how it is. Diffing support, however, even for asset files is available. Just right-click on the asset, including Blueprint, and in the source control section, you will have the menu option Diff against Depot. Definitely, this Blueprint diffing is light years behind C++ source code diffing, but at least we have something, and with extensive commenting, it could be pretty useful. Now that we have the GitHub repo, go back to Unreal Engine and select Tools, Change Source Control Settings. Select Git as provider on the source control screen. Paste the copied GitHub repo URL into the remote server text box. Make sure that the add gitignore file, add a basic readme.md file, add a git attributes file to enable git LFS checkboxes are all checked. But uncheck make an initial git commit, since before committing we will modify gitignore to exclude starter content. Click Initialize project with Git, which runs the command git init behind the scene, and a .git, typically hidden local repository folder, is created under the project folder. As a last step, press Accept Settings. Now that the local Git repo is initialized and connected to our remote GitHub repo, modify gitignore and exclude starter content. To do that, open Visual Studio and open the Bananas 5 project folder. As seen, when Unreal Engine initialized the local Git repo, it automatically staged all files. Select the content folder and click the Unstage icon. Now open gitignore and add the line content/starter content. When we save it, the number of files drastically reduced, since the entire starter content will be excluded. Wouldn't this be a problem when someone clones the repo from GitHub? Actually not, since Unreal Engine is so smart that it will automatically download starter content from the Epic Games servers when a project needs it. Now we are ready to publish our project. Enter the message Bananas map created and select the menu command Commit and Push. Visual Studio starts a background process to upload our project files over to GitHub. When uploading is completed, visit the GitHub page and check if the files are there. Now, to make sure that our GitHub repo is clonable, quit Unreal Engine, close Visual Studio, and exit Epic Games Launcher too. In Windows Explorer, rename the Bananas 5 project folder to Backup Bananas 5. Start GitHub Desktop and log into your GitHub account. You can do this with Visual Studio either. Clone the Bananas 5 repo from GitHub. After downloading is completed, in Windows Explorer, right-click the bananas5.u project file and select Generate Visual Studio Project Files. Then double-click bananas5.u project to open Unreal Engine. When asked, confirm to build the project. When Bananas map is opened in the editor, you can be sure that the project is clonable from GitHub. Now we can go on with our project and import the banana model FBX using the Content Browser import menu. In the FBX import options, just press import and let it generate a material asset too. The material asset created is called Lambert1 and it is just plain with the gray color. Later we will change this color to our nice banana texture. Now that we have a static mesh asset, we can drop the banana model a couple of times onto the game scene. Its shape is banana, but its color is gray, since the default material imported doesn't use the banana texture. Remember from the first video, when a static mesh is dropped onto the scene, actually a static mesh actor object is created. Import banana texture JPEG and Unreal Engine automatically creates a texture asset for that JPEG. You cannot use a texture asset directly in a model. We already have a Lambert material asset. Let's modify this material, so double-click Lambert1. Add texture sample expression from the palette in the material editor. Select banana texture material expression for the texture sample node on the details panel. Then connect texture samples RGB outbound connector to result node base color inbound connector. The viewport of the material editor has fancy previewing visualization feature. Apart from the default sphere, you can select cylinder, plane, and cube to see how the texture fits on that surface. As well as you can select any model FBX assets in the content browser. Then select the rightmost icon next to the cube and the material editor viewport shows the texture applied on the selected shape. This selection is not saved along with the material asset, however. Note that all the banana model objects on the game map are painted with the banana texture immediately. In our first video, this was the point when we created our bananas turntable blueprint class. In this video, we first make a C++ actor class, and then based on this C++ actor class, we will create our blueprint class. All the business logic, game algorithms are going to be implemented in the C++. And the static structure in the blueprint. We could, of course, build everything in the C++ either, but this way we demonstrate a common scenario, how game features are distributed between C++ and blueprints. In early versions of Unreal Engine 5, it is highly recommended to disable live coding because your map files might be corrupted. Unreal Engine 4 works excellently, but in version 5 it may happen. So, in Editor, Editor Preferences, Live Coding, uncheck Editor's live coding. Now, select the C++ classes bananas folder in the content browser and press Add New C++ Class. Choose Actor as parent class and enter the name Banana Actor. For class type, don't select neither public nor private. Press Create Class. At this point, Unreal Engine creates C++ files, CPP and header, and opens Visual Studio. What is this U class thing just above the class definition? It is a macro that compiles to nothing from the C++ compiler's perspective. Then what is it meant for? There is a very important tool in Unreal Engine build machinery. It is called Unreal Header Tool. This header tool parses the class header files and extracts valuable information for the runtime reflection machinery, which is used heavily in the editor and available at runtime too for the application programmers. As an experienced C++ programmer, you are perfectly aware that in C++, unlike in C# or Java, there is no built-in reflection machinery. So the Unreal Engine team had to develop their own one. You can learn a lot about it on Unreal Property System Reflection at unrealengine.com. The Bananas API and generated body are macros too, that are generated by Unreal Engine for the project. Bananas API is needed since Unreal Engine can cross-compile to multiple C++ platforms: Windows Desktop, Mac, Android, iOS. For example, on Windows, this Bananas API macro expands to DACL-spec DLL export. Generated body expands to a number of internal things that are required for the reflection machinery. The class name is a banana actor, derived from a actor. These a prefixes denoting in Unreal Engine naming convention that the class is derived from actor, so it can be dropped onto the game scene. The class has a public no-argument default constructor, which is necessary for the editor to make an instance. I didn't have the time and enthusiasm to search the Unreal Engine source code, which is anyway available from GitHub if you registered your GitHub account as Epic Game member, to find out how the editor actually creates objects from custom C++ classes. In C# or Java, the reflection machinery has the option to dynamically find a class and create an instance. In C++, however, you need a dynamic link library in Windows, and that DLL should have dynamically invocable static functions, factory functions, that can be called to create instances. The load library and get process address are the tools to find a static factory function pointer dynamically. The virtual begin, play, and tick functions have the override keyword, which is an important feature added to the C++ language with version 11. This way, the compiler guarantees that the function has an ancestor to override. Now, add a property to the class definition. uProperty edit anywhere category equals bananas. fRotator rotation speed. This property will be used in the Unreal Engine editor to define the rotation values in the 3 axes. uProperty is a macro that expands to nothing, and it is meant for the Unreal header tool too. It can accept a number of specifiers like edit anywhere or category. A property is editable in the details panel of the scene editor or in the blueprint editor when a derived blueprint class is created. The syntax is not enforced in Visual Studio. uProperty for Visual Studio is just a regular macro. For example, the category equals bananas can be written with quotes either. Category, quote, bananas, quote. The header tool will accept both formats. If you misspell a specifier, you will have an error in Unreal Engine when it compiles the class, something like this. Error unknown variable specifier edit anywhere XX. For a full list of specifiers, check out the official documentation, Unreal Engine uProperty specifiers. fRotator structure holds 3 single precision float values for rotation around the X, Y, and Z axis. fVector is another commonly used 3 float value structure for locations, velocity, and scales enlargement. The F prefix in the Unreal Engine naming conventions means framework. Now, with this new property, add this code to the ticks method. This arrow add actor local rotation, this arrow rotation speed. Of course, the this arrow parts can be left out. This statement will rotate the entire game object on every tick with the speed defined in the Unreal Engine editor. The default value is 0 on each axis. If the actor is composed of multiple components, then it will rotate the root component, which rotates its child components. In the begin play, add uelog, logtemp, log, text, rotation speeds are %s for actor %s, star, this arrow rotation speed dot toString, comma, star, this arrow get name. uelog and ueclog are the logging functions on the output log window in the editor. I always use logtemp. Log is just a regular text, warning is yellow text, error is red text. Text is a macro to enforce Unicode wide character strings. %s is the well-known format specifier for printf, sprintf, snprintf functions. fVector and fRotator and all Unreal object has a toStrings function, which returns fstring. F-vector and F-rotator and all Unreal objects has a toString function, which returns an fstring structure. This fstring structure internally has a character pointer, which can be accessed via the star operator. So, to provide this zero-terminated character string pointer for the %s specifier, you have to use the star operator on the f-string structure. This operator overloading capability of the C++ language makes it really intimidating. So, if you see some weird looking syntax, immediately think about an operator function. I am an experienced C++ programmer and architect. Still, I am not a fan of these operators either. Honestly, they make the code finicky to decipher. Anyhow, this is how it is. Just learn to live with them and be happy that at least the comma operator is not overloaded in any Unreal Engine structures or classes. GetName is a nice example for runtime reflection. Every actors have a name. The name is returned as fstring, hence the need for the star operator. These are enough for C++ now. So go back to Unreal Engine and press the Recompile and Reload C++ icon button on the bottom right corner. If there are no errors, you can drag this class on the scene. An actor object is immediately created, but note that it is sticking stubbornly to the middle 0 location, and you cannot move it anywhere else, since it has no root component. The actor itself has not even location without a root component. It can have behavior, but no physical characteristics. Note how the bananas category is displayed in the details panel, and the rotation speed property is shown too. You can even give a rotation speed value, and the begin, play, and the tick C++ functions all are invoked for this dumb actor too. To give a body to the specific actor instance, just add a static mesh component to the actor on the details panel. Even if it is not visible, it has immediately location, and you can start moving the actor around the map. Also note that this component is made as the root component of the actor. It cannot be removed anymore, but it can be replaced with some other component, and then that other component would become the root component. Now select smrock from the starter content as the static mesh property for the static mesh component. Enter 10 for the z value for the rotation speed and start the game. This was one of the possibilities to individually build and parameterize a game actor. Now let's expand this actor class and make a composite actor in a similar way as we did in the first video. But this time the Blueprint class is derived from our custom banana actor class. You have two options to create a Blueprint class derived from a C++ class. Select the game content folder in the content browser and add Blueprint class. It will then ask for the parent class. Here you have to select all classes and in the search field enter banana. And it will find our C++ class. The other option is more intuitive. Just locate the C++ class in the content browser, right-click and select Create Blueprint Class based on Banana Actor. Select the game content folder as the location and give the name Turntable with Banana BP. As in the first video, create a turntable composite actor in the Blueprint editor. Add the cylinder component below the root component with the name turntable and resize it to make it look like a turntable. Then add a static mesh component under default scene root with the name banana1 and select banana model as the mesh asset on the details panel. Add another static mesh named banana2 with the banana model. That's all. We don't need to add any event graph nodes, since the rotation is performed in the parent C++ class. Now, drag the turntable with banana BP onto the map and add some rotation speed to the actor. Run the game and enjoy your turning banana simulation application. Now that we are done, save all our project and go back to Visual Studio. Open the Git Changes panel. Enter message Banana Actor C++ class added and commit and push the changes. So, in this video, we have expanded our understanding with C++ classes, blueprints derived from C++ classes, and we learned how to enable GitHub source control. Remember that whenever an asset is modified, a full copy is saved in the GitHub LFS repo, and eventually for large projects you may have some storage size limitation on a free GitHub account.